Welcome back, boys and girls. Today, we're heading back into the forest where sunshine sparkles and math helps friends solve anything. Today, Marvin Mouse and his forest friends are building something really exciting. It's an obstacle course full of swings, slides, and racetracks. But wait, they've got some tricky adding and subtracting to do. How will they figure out what's missing? How will they know how much they need? Let's join Marvin, Sally, Gina, and Robert on their math-filled forest adventure and see what tool they use to help make playtime possible. In Helping Forest, all bathed in light, Marvin, Sally, Gina, and Robert's delight. They planned an obstacle course so grand, with math to guide them through the land. They planned for swings, slides, and beams to play some games of endless dreams. A balance beam was first in line, strong and steady, built just fine. 10 acorns long, said Gina Giraffe so tall. Sally Squirrel measured, it's short, that's all. 8 acorns now, but we need more. How many still to reach our score? Marvin Mouse marked up some bark. 8 plus what? An unknown part. 2 more acorns came the cheer. Now the beam was safe and clear. Next, they started the hopscotch plan, designed to be a 7-leaf span. But counting twice, they found just 5. 2 more needed to arrive. Marvin Mouse sketched it plain to see. 5 plus 2, yes, that makes 3. No, Sally Squirrel laughed, 7 is right. They fixed the count, it matched in sight. Last, the racetrack, long and wide, 10 units marked as a guide. The plan says start with 4, Marvin said with glee. Let's use a tape diagram to help us see. He took a log that was split in 2. 4 on one side, how many on the other will do? We need 6 more to make 10, they all agreed. The racetrack's length, exactly what we need. With every step, they made it fun, measuring beneath the sun. Breaking problems part by part, math and teamwork filled their hearts. The course was done, a grand hooray. Friends all gathered, set to play. They laughed and cheered and learned and ran. A perfect day, all built to plan. Wow, Marvin and his forest friends used math power to build their obstacle course. What helped them figure out what was missing? Yeah, a tape diagram, that's right. A tape diagram is a simple picture that helps break big problems into smaller parts. Tape diagrams help us see what we know and what we need to find. Do you think we can use tape diagrams too? Yeah, great. Let's be like Marvin and the crew. We're going to look at some new word problems together. We'll draw tape diagrams to help us add and subtract and solve with confidence. All right. Before we get into our problems, let's review the read, draw, write strategy that we've used before to help us solve. When we do this, we are going to read the problem 2 times. Remember, the first time we read just to get our information, and the second time we're really reading and thinking about what's happening in the problem. The D, or the draw, is drawing a math picture, something that would go along and help us understand the problem. And then the W for write a number sentence. You'll see us do this at the end, but that's where we're really trying to write down what we need to know. All right. So let's take a look at this example. This says, Marvin has 4 pieces of cheese. He finds 6 more pieces of cheese. How many pieces of cheese does he have now? All right, that was our first read. I'm going to read it again, and this time you're going to be thinking about what's happening in the story and what we can maybe draw. Marvin has 4 pieces of cheese. He finds 6 more pieces of cheese. How many pieces of cheese does he have now? Okay. Now, I am going to draw a rectangle for the first part I know, which is 4. So I'm going to go right here and put a 4. Okay? Next, I'm going to draw another rectangle for the second part I know, which is 6. Now I'm going to draw this one a little larger because I know that 6 is larger than 4. Okay, so I have my 4 and my 6. Now I'm going to draw these lines to the top. Do I know the total amount of cheese that Marvin has? Well, you at home might know because you're super smart, but the story problem didn't tell us yet. So I'm going to put a question mark up here at the top to show that I don't know the total. Now, does this remind you of anything that we've already learned? Yeah, me too. It reminds me of a number bond, and it works similarly. So part, total. Now, back to our problem. We've read twice, we've drawn a picture, and now we're going to think and write a math or number sentence. So I'm going to take what I know here. I had 4 pieces of cheese, or Marvin did. We are adding another 6. And then I need to know what that answer is. So I have my part, and my total. Now, I think what I'm going to do here, I know my numbers to 10, and I know you do too. But I think what I'm going to do is start at 4 and count on 6 more. Okay? So I have 4. I'm going to count on 6 more. So I have 4, and then I'm going to add 1, 2, 3, 4, 5, 6, and that gets me to 10. There are multiple strategies, multiple ways we could do that, but that's what I chose today. So this would change then to a 10. My math sentence would now say 4 plus 6 equals 10. And then the sentence, I'm just restating what I wanted to know. Marvin has blank pieces of cheese now. He has 10. Now, you're really good at solving addition and subtraction problems. We've done this a lot. This is our focus for today, is that tape diagram and how that picture can help us. Let's try another one. Gina has 8 leaves on her plate. Sally gives her 2 more leaves. How many leaves does Gina have on her plate now? That's our first read. Second time. Gina has 8 leaves on her plate. Sally gives her 2 more leaves. How many leaves does Gina have on her plate now? Now I'm ready to draw. Now I'm going to think through this the same way I did the last one. I'm going to start with what I know. Gina has 8 leaves on her plate. In the past, we would have drawn a picture of maybe 8 dots. Then we would have drawn 2 more dots. This is giving us a different way to visualize and see our picture. So I'm going to do a long rectangle for 8. 2 more. Now I can make this a pretty short rectangle because I know that 2 is quite a bit smaller than 8. Again, I don't know how many leaves Gina has altogether, so that's why I have the question mark at the top. Again, if we were kind of comparing this to a number bond, this would be our part, and our total. So our question is, how many leaves does Gina have on her plate now? I can see here that all this added together is going to be my total. So I'm ready to write my math sentence. I'm going to say 8 plus 2 equals, and this would be my question mark. Now I could do this again on my fingers, but this time I'm just orally going to count out loud with 8 and go on 2 more. So I'm going to say 8, 9, 10. I added 2 to my 8, and again, my answer is 10. So I'll change my question mark here. And my statement, Gina has 10 leaves on her plate now. Give me a quick check back at home. Give me a thumbs up if you think you've got it. Thumbs to the side if you're almost there. Thumbs down if you need one more practice. Okay. I see a lot of thumbs up. I see a few people who said that they would like some more practice. So let's do one more. All right. Oh, Charlie Chipmunk. We haven't talked about him in a while. Okay, Charlie Chipmunk collected 12 berries. Then he finds 8 more berries. How many berries does Charlie have now? Okay, let's work through this one the same way. Except, what am I forgetting? Yeah, I need to read the story again. So here we go. Charlie Chipmunk collected 12 berries. He finds 8 more berries. How many berries does Charlie have now? Okay, now I'm ready to draw my picture. I'm going to draw my 12, pretty large rectangle. My next number is 8. He finds 8 more. I'm going to add those on. Is 8 bigger than 12? No. So a little bit smaller rectangle. You can see how the rectangles are reflecting the size of the number inside. Okay, and then I'm going for my total, which I don't know. All right, I'm going to go ahead and write this. 12 plus 8 equals something. Now, these numbers are a little bit bigger than the last two examples. So I think what I'm going to do today is I'm going to make a friendly 10. I think that might help me. Now, if you were with me, we've done this before. If you've learned this someplace else, that's awesome. And if you don't know what I'm talking about, hang with me. I'm going to change my color just for a minute so we can see. If I'm adding these, I'm going to break apart the 12 into a little friendlier number. So I'm going to use 10 and 2. So I know that 10 plus 2 makes 12. The reason I did that is because I know 8 and 2 also join together to make 10. So then I can add my two 10s here and get what number? Yeah, 20. So I know that this up here is 20 and this would also be 20. So we're using a lot of different strategies in one problem. So Charlie has 20 berries altogether. Read the math sentence with me. 12 plus 8 equals 20. You guys are really working hard, and I think you've got the hang of this. So let's try a few more together, but let's use what happened in the story to help us explore some different types of problems. All right, so let's take a look back here at the story. A balance beam was first in line, strong and steady, built just fine. 10 acorns long, said Gina Giraffe so tall. Sally Squirrel measured, it's short, that's all. 8 acorns now, but we need more. How many still to reach our score? Marvin Mouse marked upon some bark. 8 plus what? An unknown part. All right. The friends here are building a balance beam that they will need to be 10 acorns long. They already have 8 acorns, so how many more do they need? Now, I'm going to pause right here and show you right here on the slide how we could do that using what we've just learned. So let's see. We have 8 acorns. Uh-oh, now what? I know the one part, but I don't know the other. So I'm going to need to use a question mark here. I know the 8. How many still to reach our score? Now, I do know the total. The total is what? Yeah, it says right here, 10 is what they're wanting it to be. So now if we were looking at this like a number bond, I have my total, I have one part, but I have an unknown part. We've solved plenty of these in the past, but it looks a little different with the tape diagram, but it can still help us. So now I can write either an addition or subtraction sentence. Marvin Mouse says 8 plus what? So I'm going to stick with his addition. Now, I am running out of room, so we're going to pop up here at the top. We need to figure out, whoops, I need to write my sentence. 8 plus something equals 10. Now, we need to figure out what to add to 8 to get 10. So there's lots of strategies we can use. But again, I'm going to orally count on from 8 since I know it's close to 10. And we just did a problem close to this. So I'm going to say 8, 9, 10. And what's my answer? 2. All right, so that means this would be a 2. And I could change this. I wonder if I can just magically turn that into a 2. It's not great, but it works. 8 plus 2 equals 10. Excellent work. Now, here's another problem from the story. Next, they started the hopscotch plan, designed to be a 7-leaf span. But counting twice, they found just 5. 2 more needed to arrive. Marvin Mouse sketched it plain to see. 5 plus 2, yes, that makes 3. No, Sally Squirrel laughed, 7 is right. They fixed the count. It matched in sight. Okay, the friends are measuring a hopscotch game that they need to be 7 leaves long. They already have 5 leaves, so how many more leaves do they still need? Now we're going to do the same thing and right on top of the story. I know one part, okay? They found 5. So they have, 5 here. Now, I do not know the other part. They kind of talk about the numbers, but they've messed them up a lot here. Some were adding, some were subtracting. So we're going to do it this way. I don't know my other part, so I'm going to put a question mark in there, but I do know the total. Now, I'm going to keep going with my addition sentences. I know that 7 is what I need because it says it's designed to be a 7-leaf hopscotch. So I'm going to move this up here and make my math sentence. So I have 5 plus something equals 7. Now again, I'm going to stick with the strategy I was using before and just orally count on from 5 because we're pretty close to the number. So I'm going to say 5, 6, 7. How many am I adding in? 2 again. So I could go ahead and change this. This would be 5 plus 2 equals 7. Say that with me. 5 plus 2 equals 7. Awesome. Let's keep rolling. All right. Last, the racetrack, long and wide, 10 units marked as a guide. The plan says start with 4, Marvin said with glee. Let's use a tape diagram to help us see. So I'm going to pause right here. This is where we're actually seeing our math vocabulary. He took a log that was split in 2, 4 on one side. How many on the other will do? We need 6 more to make 10, they all agreed. The racetrack's length, exactly what we need. Now, we've already kind of told the answer here, but we're going to see how we could have got there with a tape diagram, especially since they mention it in the story. So the friends here are measuring their racetrack with logs. They have one log that shows 4, and they have to figure out how many more is going to be on the other log to get them to 10. Now, again, here we go. I know one part is 4. I don't know the other part, but I do know the total. So I can set it up just like that. Now I'm going to keep with those addition sentences since that's what Marvin started. And we need to figure out what are we going to add to 4 to get 10. So I have 4 plus something gives me 10. Again, we have a lot of strategies. This time, let's count on our fingers from 4 to 10. All right, so we have 4. We're going to keep going to 10. Ready? So 4, 5, 6, 7, 8, 9, 10. How many more did we just add? 6, right? So that means that our mystery number here, our missing part, would be a 6. Okay, let's read the math sentence together. 4 plus 6 equals 10. Awesome. You guys are truly amazing mathematicians. Now, we can also use tape diagrams to solve problems when we're comparing different totals. So I'm going to have you listen to this word problem, and then we're going to apply our read, draw, write strategy again and use a tape diagram to help us solve. Let's get that cleared off. Okay, so let's take a look here. Todd and Elaine like to build with blocks. Todd builds for 10 minutes, and Elaine builds for 7 minutes. How many fewer minutes does Elaine spend building blocks? Okay, that's a whole lot. All right, so thankfully we get to read it twice. So let's listen again and start thinking about what we might be drawing or what is it that we're really trying to find. Todd and Elaine like to build with blocks. Todd builds for 10 minutes. Elaine builds for 7 minutes. How many fewer minutes does Elaine spend building blocks? All right. So that time as I was reading, I was thinking, what could I draw? Well, I know how long Todd builds for. So I'm going to draw a rectangle to show Todd's minutes. So that's a 10. Okay. I also know how long Elaine spent building. So I'm going to make a rectangle for her also. That is less helpful. Let's see. Well, now I'm stuck. When I'm using my drawing like this is going to tell me how long they build with blocks together. which 10 plus 7 would be 17 minutes. But is that what our question is asking? Is it saying how long do they build blocks together? It's not, is it? It's asking how many fewer minutes does Elaine spend building blocks than Todd? I think we're going to have to change our picture. So I think what we need to do, you may have been with me when we were comparing length of objects a couple lessons ago. If you weren't, that's fine. But what we learned is when we're comparing objects, we have to match them endpoint to endpoint. So for example, if I was going to compare these lengths, I couldn't just hold them like this and guess. I would need to lay them down, match up one of the ends, and then I could see that this pen is longer than this clicker that I'm using, okay? So I think because we're comparing time in this problem, we need to do the same thing here. So hang with me, let's try this. Todd builds for 10 minutes, right? Elaine builds for 7 minutes. So I'm going to do just what I was doing with those objects, and I'm going to draw another rectangle underneath here. Now, 7 is smaller than 10. I know that. So I'm going to make that a little smaller. Now, I have to have a missing part somewhere. It looks like this might be the total. So I'm trying to find something right here. What is the difference? I don't like how I drew that. Let's try that again. What really is the difference? What's missing right here? Todd builds for 10, she builds for 7. What's missing right here? Now I can write my sentence. I could do this 2 ways. I could do addition or subtraction. We've done a lot of addition. I'm going to try subtraction this time. So 10 minus 7 is going to give me what's missing, which is that little guy. What is 10 minus 7? You figure that out at home and yell it out at me. Yeah, 3. Okay, I saw someone use their fingers. I heard several people yell it out. So I could change this. Whoops, I could change that. And we would say that 10 minus 7 is 3. Now, can we answer our question? Elaine spends blank fewer minutes building blocks. Well, yeah, now we can answer it. 3 is our answer, but 3 is the number of minutes that she spent less time. He was building for 10. She was building for 7. 7 minutes is actually 3 less than the 10. A little confusing, but do you see where we're going with that? Okay, I think we have time to fit one more in, and I think that would be helpful. So let's look at this one. Okay, Kel and Kate do their chores on Monday. Kel does his chores for 14 minutes. Kate does her chores for 10 minutes. How many fewer minutes does Kate spend doing chores? Let's read it again. And this time be thinking. We've seen an example, so this time be thinking about what kind of picture we would need. Kel and Kate do their chores on Monday. Kel does his chores for 14 minutes. Kate does her chores for 10 minutes. How many fewer minutes does Kate spend doing chores? Now I know what to do. I'm going to draw my first one. This is Kel, 14 minutes. Now I know I'm going to compare. So when I'm comparing, I'm going to have the same endpoints lined up here, and there's Kate's. All right, so Kel did 14 minutes, Kate did 10. I need to know how many fewer minutes. So I need to know where's the difference right here. This would be our question mark. So my math sentence would look like 14 minus 10 equals something I'm missing. You could also, if you're more of an addition fan, you could have 10 plus something equals 14. We're going to get the same answer either way. Okay, let's do addition. Okay, so I have 10. I'm going to count on until I get to 14. So say it with me, 10, 11, 12, 13, 14. How many more did I just add on? 4. So that means the answer here would be 4. And the number here would be 4. And that would be 4. So, can we answer our question? Kate spends 4 fewer minutes doing chores. Great job. Thank you for sticking with me for that. We've done a lot here today. You can look for ways that you can do addition and subtraction at home. Let's say your dad is baking cookies. He bakes 20 cookies. Your little sister and her friend eat some of the cookies, and now there's 11 cookies left. How many cookies did your sister and her friend eat? You could use a piece of paper and write it out. You could use strips of paper. I brought these little index cards, and you could fold one to make a shorter group. So you'd have your longer group and shorter group. You could do it that way. You could do it on a whiteboard if you had it at home, sidewalk chalk outside. Lots of different ways that you could practice this. So I want you to do that. I want you to come up with some ways that you can practice addition and subtraction at home. What a day with our forest friends. Thanks to teamwork, careful thinking, and a little math magic, Marvin and his friends built the perfect obstacle course. They used tape diagrams to help them figure out what was missing, how many more acorns they needed, and how parts come together to make a whole. When we add or subtract using tape diagrams, it's like building a picture that shows us the answer. So the next time you're stuck on a math problem, remember Marvin and his crew and draw it out just like they do. Boys and girls, it has been my absolute pleasure to spend the past few weeks with you. We have learned so much about math and the world around us. I hope you keep going on math adventures every day and learning all that you can. Thank you so much for joining me. Goodbye.